Alright, Chapter 9, Controlling Assembly Configuration and Display States. Assembly configurations enable you to control many things, include part configuration, suppression, visibility, color, assembly feature size, assembly layout, sketch dimensions, mate values, suppression states. In this chapter, you will learn about related topics such as the design table, speed pack, derived configuration, and display states. Display states are better performance alternative to configuration, controlling visibility, display styles of an assembly display state options discussed in length of the chapter. In this chapter, you will learn to change visual properties of the display states using assembly configuration to manage large assemblies. Work with the assembly configurations tutorial using display states. Display states enable you to change visual property more quickly, efficient with the configuration and assembly. Drawing with the configuration can be slowly changed with only one configuration to another, whereas you change between the display states almost instantly. Assembly of the display states can also control display states with different instances of the part, and assembly can be used with different display states. Display states can be used with the part and assembly for drawings that can have the great impact on assembly and drawing work. Assembly display states also have the huge impact of drawing performance, whatever drawing reference multiple configurations. Same with assembly rebuilds, refurb with the general configurations loaded with the resulting model into RAM. So far, 2 configurations, 2 assembly load with 3 configurations, 3 assembly loads, and so on. Display states are more efficient. Much more efficient because only one set of the model data is loaded and symbol flags control of component visibility and appearance. Controlling display state configurations. Display states can either be independent configurations or linked to them depending on your settings. The control of the display states, use the display plane pop out with a click and then double arrow icon upper right corner of the feature manager, and you can also press F8. Figure 8 19.1 show the display plane action along with the assembly showing the different. Alright, 19 show the display pane, assembly parts, and the differences. Display states. The column size symbol of the display pane is follows. The cross over the eye hides or show the part. The box displays each of the component. Appearances, transparency, default display, component part number, pattern, component and part color. Appearance overrides are settings of the apply card different than X with the model geometry with their hierarchy in which appearance applied with the appearance applied with the feature may override or be overridden by another appearance applied with the part of the individual face. These appearances override hierarchy as summarized here, shown with the highest priority at the top. Assembly component face, feature, body, and part. So you can read into these part appearances overridden by either every other type of appearance. Appearance applied with assembly overrides everything else. If you override the appearance of the display mode of the component in the subassembly and the upper left-hand triangle appear with the display, you can remove the override from the left mouse button or the right mouse button menu. Figure 19.2 show the left mouse button menu for the component and subassembly overrides. So we went through the assembly view, left mouse button. When you select clear override, Solidworks clears overrides with the currently selected component, clears all top level overrides, clears all overrides of the subassembly, the entire top level assembly. There's no intermediate option to clear all top level overrides for the particular assembly. If you want to distinguish between overrides of that level, you need to clear the several individual overrides. The option is remove the overrides do not affect with the top level of the components. Active the display state. Appear with the angle brackets with the configuration name and with the file name of the top manager with the shown of the image. On the left, figure 19.3, the display state with the graded manager in the panel bottom of the configuration manager as shown in the image of the right. Figure 19.3. To create a new display state, simply right-click on the display plane and choose Add Display State Alternate. As alternative, you can isolate with the components you need to show, then click the Save the Icon Isolate table to create a new tab. So we went down here to the display state, we've right-clicked it, it gives us configuration of the display states tab. SolidWorks allows you to open display states right from the open dialog. This may be the big time saver of opening a very large assembly may be good, but used to the display states. Use the display states with drawings. Display states can show on drawings if only show the high parts of the display states. You can still display pages with the drawing first, display the state chain with the display mode, wireframe shader, and so on. Work properly if you must set the view on the desired display mode and select with the display state with the property manager for the view. Using part display states and parts can be have display states including separate bodies within the parts. The control of the part display with a specific instance of part within some of the component properties of the dialog box. Part display states offers some of the advantage of some of the display states, mainly display speed, especially with the compared configurations. Understanding assembly configurations. Assembly configurations are used with many different purposes, including assembly performance, simplified assembly variations of assembly with a different position for the shape of the manufacturing assembly process, and many other. Like part configurations, assembly configurations can also have a few best practice suggestions. Configuration settings, assembly control how the assembly appears in the bill of materials, what happens with the part feature matrix with the added with the other configuration, and so on. All those use the assembly configuration discussed in this chapter. Applying configuration for performance. Assembly configurations are some of the best tools that make working a large assembly easier. They can either several techniques to improve the speed working with assembly. Selecting a method appropriate to the situation important because each of the method is strengths or the weakness. Suppressing components and features the most obvious for the configuration. Improving the assembly with speed with the configuration. Simple configuration with a suppressed compound. When the suppressed components are not loaded or displayed, some of the memory of the video power conserved. Remember that you can use the folder parts and suppressed folders as an alternative to create selection sets of components and compress those sets. They are just if you're just using configuration to hide parts, consider using display states because they are more efficient for those purposes. Remember the speed pack is a subset of the configuration. Speed pack is a simplified representation enabling you to select faces by to represent an entire subassembly for the performance reasons. Scheme that you may want to use for suppressing parts need to have one of the following: configuration, isolate functional areas of the assembly function, remove the faster and purchase components, configuration, remove the complex parts, leave only with the parts in context relation, figure the suppressed patterns and assembly features, assemble configuration, there's simplified configuration, show the assembly of different position variation, assembly with the different parts configuration. If you suppress the ground part, any other part that connects the group of parts, keep it in mind that this causes the other parts to float in space as unattached. Obviously, there's not a good situation, and you should avoid it as possible. One way to avoid it is use assembly layout sketch mate with the parts with the sketch instead of the ground part. Assembled for the components of other items is suppressed to improve the performance, such as assembly feature component patterns. And do you really need to see all the parts pattern around the assembly to work on the simplified representation? You may be able to suppress these parts. If you feel you cannot suppress the parts, please consider using display states to hide parts that need to complete the parametrics do not need to display. Alright, configuring speed pack. Speed pack configuration that uses only with the display of data selected face of the body of the represent the entire subassembly instead of opening all the parts in the assembly. In fact, the speed pack stores the geometry in the assembly file that doesn't have to open any part of the files at all. Further, it stores the geographical with the graphic triangles for all components body data with selected face of body. Speed packs are mentioned because they are a form of configuration, essentially derived configuration. As a result, have the top level assembled configuration on the subassembly to use the speed pack that is extremely helpful in very large assembly drawing performance. Using part configuration for speed. Simplified part configuration consists of configuration cosmetic features such as small fillets, extruded text, and other cosmetic details that are suppressed. Assembly configurations can use the different part configurations with it. Examples would be enabled to make the assembly configuration called simplified or all, and a reference is all simplified part configurations. Other new special operations. Assembly configuration. Open the dialog box, include creating a new configuration. All of the components suppressed enables you to achieve the instruction with the assembly with revolving the components. Another option is to open the assembly of the new configuration where all the components are resolved. Beyond that, open the dialog box enables you to select the specific configuration. Open that you do not have to wait for the last figurized load. Then make the change. Getting familiar with the advanced component selection. Alright, Advanced Component Selection dialog box figure 19.4 is formerly called the Advanced Hide and Show and Hide components. You can access the dialog box, right click with the configuration name, configuration management, and select Advanced Select. This tool enables you to establish searching criteria, show, hide parts, and criteria. Multiple criteria can be used to sort and retrieve the tools generally underused on people who often are surprised to find it in the software. Category 1 options enable you to search on the things with the document name, in context, property mass, other standard Solidworks information. Category 2 can either custom property information structured options. Category 1, such specifically in context conditions. Looking at an isolated function. Isolate works like an inverse hide command. Select multiple parts, clicks isolate with the right menu mouse button menu. The selected parts remain shown. Everything else becomes hidden. A little pop-up menu gives you the option to show the removed components of the wireframe transparent display mode or save current display as a new display state. This is a very useful function shown in figure 19.5. Controlling display performance. Overall, SolidWorks performance is split into two categories: CPU as processing, CPU as graphics processing unit processing. Which each function of the computer perform better depends on the hardware driver of the system, maintenance among other factors. While trying to speed up the performance of assembly may make the biggest impact with reducing load on the CPU and GPU. You can do this by suppressing a part when the part is suppressed and neither calculated or displayed. The means of the load of each processor for this part is 0. When you hide a part parametrically, the feature is still calculated and by a CPU. However, the base code of the part with the hidden does not create a load on the graphics processor unit. You have the good main processor questionable video card. You will achieve greater benefit from removing graphics load from your display and simply unloading hidden compartment for unload the hidden compartment for the RAM. Alright, isolate the figure 19.5 isolate function creates display states. Alright, using lightweight part settings. If you want to show the part but not calculate the parametric relationship between lightweight parts, if you can access lightweight default settings with the tools option on both assembly and performance pages, you can make the part lightweight with the right mouse button menu. The opposite of the lightweight resolve. The resolved meaning with the part is fully loaded with the parametric loading and calculated with the CPU, and graphics display data is calculated as shown by the GPU, and lightweight by the data is loaded along with the reference geometry feature mates for the top level component. Graphics data will also be computed with the current session of both resolved and lightweight modes. LDR mode is a only mode where the graphics data is ready for the file but not computed in the session. Working with SpeedPack. There's some confusion as about SpeedPack functionality failed in the scheme of things. The SpeedPack parametric will not load with the graphics in addition to some of the geometry is selectable as if it were imported geometry, actual geometry without rebuild parametrics. However, the SpeedPack applies only to the sub-assemblies when the needed improvement is much higher. There is 5 relations to the resolved SpeedPack lightweight hidden suppressed states are shown figure 19.6. Comparing resolve to unsuppressed. The terminology becomes a little convoluted here because of the relation between the 5 different states of the part of the feature state with the easy to remember because the feature becomes either suppressed or unsuppressed. However, the sum of there are 5 states instead of 2. Unsuppressed could mean anything but that is not suppressed, which still leaves 3 states. For this reason, resolve is used instead of unsuppressed when dealing with a component in an assembly. Relationships among resolved SpeedPack, lightweight, and hidden suppressed. We got resolved all parametrics display data is fully loaded. SpeedPack no parametric graphics loaded. Some selectable geometry hidden. All parametrics no graphics. Lightweight no parametrics graphics loaded. Suppressed no graphics. No parametric graphics, and that works from slower to faster. Using configuration for the position. When you use the configuration display with some of the various positions, you can do either the change of the mate, change the layout, sketch configuration. Configurable in 2 ways. Masters can be suppressed, unsuppressed, with the angle, distance, mate's value configured in the same way the sketch dimension can be configured. Although creating a mate scheme enables you to reposition the assembly of the mate suppression state with the values essential to the method, it may not be the best approach. What must be suspended with the components move if and then mates for the later unsuppressed. The assembly may not return. Real position mate can be often solved by different orientation made, flipped, and turned off and on this way. Using skeleton layout sketches may make part of the better approach, although also with the drawbacks may have the layout sketch you cannot dynamically assemble the motion. If you use the mate scheme discussed previously, the generally means to have a fully defined assembly that does not allow dynamic assembly motion. As a compromise, good way to handle this is by using configuration dynamic assembly motion with 1 or more open degrees of freedom. You can use the other configurations fully defined mechanisms shown in the particular position using either method, probably with the best way to demonstrate the idea with the example using a robot arm assembly. Alright, positioning mates. First, look at the position of the mates. Open and assemble the such for the one. Goal of the position of the grippers. You can do with a couple of ways, both directly and indirectly. And assemble you for the chapter. Grippers have the rebuilt sub-assembly, which allow the different types of the control of the nodes for the sub-assembly configuration. Closed position. One of this allows the dynamic assembly position motion. In addition, sub-assembly is being solved with a flexible figure. 19.7 show the assembly and feature manager. So 19.7 show the use of the example. Driving the position directly. A sketch point has been added. Sub-assembly identified with the precise point of the gripper that has been positioned. Sketch points have also been added with the main assembly to represent the parts needed to be picked up with the robotic arm. The derived configuration under the default configuration notes that when you switch with the plate between the current configuration, the part seam to separate, move the one over the links, cover the parts to snap back together. The problem becomes there are so many options that when moving between configurations, software had difficulty choosing the final position. This is definitely with the potential problem. Even the configured mates is shown in assembly in various positions. Notice although the grippers are positioned correctly, the arm is still allowed with a swivel around with the intent of the target point. You can correctly defining orientation grippers of each location. Additional pivot where added with the assembly defining the parts would become difficult. More difficult, the arm would not be able to reach any additional points, but it would not be limited to the orientation gripper at each point. Driving position indirectly. You can either mate for the drive of the gear position assembly, either the series of the angle made for the making the difficult to become. Because of the particular location, you have to do some of the calculation, but the angle made for the more stable assembly, relying on the moving the parts for the unconstrained position. If the cycle through the derived configuration, indirect top level configuration, you may note that the mates are not suppressed or unsuppressed instead of the value of the values are changed. This makes it more difficult to position the grippers precisely because it's specific about position individual parts. There is no ambiguity positioning with sketches. Although techniques still use the mate to the position, the parts of the chain with the position is changed with the sketch dimension rather than mate values. Sketch use the derived parts for the assembly, sometimes called layout sketches and skeletons. They are discussed in Chapter 16, working with assembly sketch and layouts for working context top-down assembly techniques. Figure 19.8 shows the assembly that used for the rest of the chapter. 19.8 shows the position assembly components, assembly the particular assembly driven the two sketches for different plane with the given govern the position of the parts. Keep in mind that the assembly has been used for all other techniques as well. That means all the techniques can exist and simultaneously controlled by the configuration. Examine the assembly to see how the parts are mated to the sketch. This is important that the first time they create the part such that may be tempted to mate part planes to the sketch lines. Caution, be aware that mating planes of sketch lines have serious drawbacks unless otherwise type of mates which have alignment that you can control plane to sketch plane. Mates cannot be aligned. This means that the software may not align elements correctly and plane to blind mate. Alright, best practice. Better way to mate two part planes to sketch line is temporary access through the joints which sketch endpoints to solve the alignment problem. Applying configuration with a product variation. In case of the product variation of the side of the part, replace with some of the example of a 4-foot cabinet, an 8-foot cabinet, or a 2-button mouse and a 3-button mouse. Simple example of figure 19.9, the familiar robotic arm assembly, but with a variation. One of the arms has been replaced in the sub-assembly. Sub-assembly has placed the original, but replaced the part with the configuration. Their configuration sub-assembly, which again being used as a flexible assembly. Through the course of the chapter, the robot arm assembly have greatly increased the complexity of the retain with the original information first version. Maintain valve with the assembly depth through the managed configuration of difficult, but it takes a simple mistake to wipe lots of the assembly configuration data out. Appropriately, the next section to discuss the assembly design table. Using the design table to assemble the configuration change. Close chapter augments for the information you need to how to design the table to effectively assemble the design table to do everything the part design table to do except for the selecting configuration with the base part with the split parts, which are not valid assembly function. Assembly design table can also do some things that the part design table does not include the following: expressing the state of the part with the R for resolved, S for suppressed, assignment of the component configuration, assemble configuration, enabling you to activate never expand in bill of materials option. Figure 1910 shows the design table result of the auto creation using a robot arm assembly. Some of the columns being hidden with small enough to fit on the page. If you want to see the entire table, you must open the assembly. If you have the design table, you probably want to open and separate the window option, which is easier to navigate the control. Working with a modifying configuration publisher. Modifying configuration interface for the dialog box. You create the configuration with the configuration dimension for each of the custom properties of the part. With the assembly as well. Sometimes you replace the design table. You do not need the advanced functionality of Excel. Configuration publisher with the grade of the property manager that pops up with the part place and assemble the property manager and able to use select configuration to go into the assembly create, but also create with a new configuration demand inside of the constraints defined with the configuration publisher. It's greater than the assembly visualization of the possible variation. For example, the catalog crane vendor, the configuration publisher is available. The assembly means that you pop up the property manager when assembly is placed into other assembly as well. Library, some of the assemblies may be less common than library parts, wherever the pop up the property manager would be used in best effect. Both tools are useful in managing assembly configuration. Design tables are often most complete control, but they also have some drawbacks associated with the TAD Microsoft Excel. Both modified configuration publisher or internal Solidworks, regardless of level of the software, have them been purchased. If you use them, you can be sure that whatever you send data can be accessed with functionality. Alright, looking at some of the configuration do's and don'ts, some of the configuration, some of the potential pitfalls that could avoid with the paying attention for some of these do's and don'ts. Avoid using detail with the editing option, working configuration, delete with the forever, remove the items with the all configuration. Avoid using the context relation to the side of the parts without using the configuration, the side of the parts, non-configured part driven configuration, part of the cover, the confusion. Avoid using the configuration with the representative documentation control type version revisions. When people attempt to do this, ultimately limits of the kind that is they can make it their parts and assemblies if far too easy to make the mistake to wipe out all of their work in the end. If this is not a variable technique, if you're working with a manually created configuration, you should create a new configuration, activate it before making the changes. Otherwise, you will end up trying to set the variable configuration back to the way it was. Remember to select the this configuration only option for the chain with the dimension instead of leaving the default all configuration setting. Tutorial, working with assembly configuration. At the beginning of the tutorial, open the assembly name chapter 19 bag start with the tutorial solid assembly file, SolidWorks assembly. The file contains all the aspects of the needed work with the chapter, including the sub-assembly, motion configuration, and part configuration. Learn how to work with the assembly configuration. The following step: prepare to use the configurations, putting the feature manager window into upper lower planes. Place the feature manager on the top, configuration manager on the bottom. But before starting making sure the assembly adds the top level configuration, they will need these files: small tires, motion configuration, skeleton drive position, mating drive positions. Configuration will list alphabetically. Make sure the advanced option for each configuration are set to suppress new features and mates and suppress new components. Activate small tires configurations, and figure 1911 shows the features up to this point. Open the front wheel assembly, open the window, switch to the configuration menu to add the configurations called small tires, change the tire with the configuration called the small tires, which already has been created. Switch back to the main assembly window with the control tab, right click with the front wheel, assemble the feature manager, select with the component parts, select with the small tires configuration, front wheel assembly shown figure 1912. Repeat steps 4 through 6, the rear wheel assembly, double click with another configuration from the list, watch the assembly chain with the small and fat tires. Chain with the motion configuration, right click with the stem fork with the assembly, select with the component property with the assembly, solve with the flexible, exit with the dialog box, check with the C with the fork linkage mechanism, move with the dragging the force, some of them note that the force works on the front, but the front wheel does not move with it. The bike design is not yet complete, so you do not need to worry about this at this point. Putting the front of the wheel with the fork assembly could be used to make the wheel move with the fork. Switch to the skeleton driven position configuration, display the assembly layout, top feature manager. Create 2 new drive configurations, skeleton drive position configuration, one called default position, other called compressed position. Activate default position configuration, make a coincident mate between the top wing over the chainstay part and sketch line associated with the 1913, again where the wheel does not move at this time. 15. Activate the compressed position configuration, make the coincident mate between the same plane and the line angled at 10 degrees. For the configuration, you also need the advanced option and also view the top level of configuration. Step 3. If you do not do this, you may need to suppress unwanted mates manually with appropriate configuration. 16. Switch the mate driven position configuration. Chain with the stem forward with the assembly of flexible sub-assembly. Right click with the retrieve the component property solve as flexible. Add new derived configuration called 1, 2, and 3. We're creating new configurations, then ensure the suppress new feature mates and suppress new components. Options are selected to leave the one configuration activated. Make an angle mate between the bike, assemble the top plane and the face of the link as shown figure 1914. 19. After the mate is complete, double click with the angle dimension you have the double click of the edge of the mate with a display with the zoom and then zoomed out to see it. Chain of the value with the 18 degrees again. Chain of the fork from the fly unexpected location. Pressing Control Q brings it back. For the configuration 2, unsuppressed angles might be made in step 18. Chain of the value of 25 degrees. You may have the chain of the configuration 2 flexible, although it should inherit property with the parent configuration. Note you need to set the fork assembly to solve the flexible each of the configuration. You may also need to control the alignment of the alignment manually for each configuration. Alright, bottom line, display states assembly can save a lot of time if they change fast the configuration. Other more options of visualization include mixed display modes. The assembly design table can be used display state, driven by many other parameters and assemblies. Remember the modified configuration publishers work in assemblies as well as in parts. Assembly configuration is a very powerful tool, product variation, performance, especially when combined with a speed pack. Master, list all the 3 reasons for the conditions under the which the display states instead of configuration. List all the 3 reasons for the design table when working with the assembly configuration. Explain the difference between hidden and lightweight modeled states. Chapter 20, Modeling in Context.